Let's come on here. Okay. So yeah. Okay. Alright guys, so like I was saying, we're back here with the functions for grade 10. So let's get right into it, guys. Let's get right into it. So hopefully we can cover a lot today. For those that are joining my live for the first time, if you are, and it's the first time ever, guys, I have a YouTube channel. The link is in the bio. You can check it out. It's called Maths is a Game, and I do all these live sessions that I have here. I post the videos that I'm done with in the actual YouTube page itself. So I'm busy with grade 10 functions at the moment, and I just want to give the grade 10s a chance to really get immersed in these sort of like live sessions, you see. Leonardo, it's already there. The video is already there. It's uploaded, both the previous days and basically the one that I did. So they are there. They are there. Okay, so yeah, let's look at this, guys. We have f of x is equal to 3 to the power negative x minus 3. Can someone in the comment section tell me what type of function is this? Okay, I think I'm gonna do this a lot. Just gauge what you guys understand is the function. Okay, no problem. Okay, so what type of function, guys, is this? Thank you, Lerado. It's an exponential function. Okay, 3 to the power negative x minus 3. Okay, and you can see that the exponent there is a negative 1. And typically when we write the actual form of the function, we would rather have a function where the exponent is positive, all right? And that's very important. Okay, so obviously there's things that we can do to ensure that that function is positive. And what we can do is we could rewrite this as 3 to the power negative 1, the x on the outside, then of course that means 1 over 3 to the power x minus 3. Okay, because questions can come from this particular function that you have there, and they can ask you what's the value of a and b from the given form. All right, so when you have converted this given form into the actual general form where the exponent is positive, then you can see, oh, okay, the a value is actually 1, and then the b value, which is the base of the variable exponent, is actually 1 over 3. But you won't be able to see that unless you convert the form of the exponential function from its negative exponent form to its positive exponent form. So I move from 3 to the power negative x to 3 to the power negative 1 raised to the power x, and then I convert that 3 to the power negative 1 to 1 over 3, which is basically how, guys, from the laws of exponents, I hope you understand that a to the power negative 1 can be written as 1 over a, just like a to the power negative 2 can be written as 1 over a squared. And the logical flow of this writing negative exponent to a positive form is making sure that when the base is raised to a negative exponent, that particular base changes position. So from being in the numerator, the base changes to being in the denominator. And then what happens is that the exponent that is negative changes to an exponent that is positive. So it's the same thing here. A to the power negative 2, whenever a base is raised to a negative exponent, that particular base changes from the numerator to the denominator, and then the exponent changes from negative to positive. So that's why we have 1 over a squared. Okay, and that's very important for the conversion of a negative exponent to positive. So that's why 3 to the power negative x is actually 3 to the power negative 1 raised to the power x. And then obviously this 3 to the power negative 1 can be written as 1 over 3 to the power x. So our exponential form now is actually in the correct suite form, where I can tell you now what the value of a is, what the value of b is, and really what the value of q is for that function. Let's come here. What type of function, guys, is this? G of x is equal to 3 over x minus 1. What type of function is this? This is grade 10, guys, okay? G of x is equal to 3 over x minus 1. What type of function do we have here? What type of function is g of x is equal to 3 over x minus 1? Remember, for the grade 10 syllabus, 4 types of functions. We have straight line or linear function, 2 quadratic or parabola function, 3 exponential function, or 4 hyperbola function. So what type of function is g of x is equal to 3 over x minus 1? Is it linear or straight line? Is it 2 parabola or quadratic? 3, is it exponential function? Or 4 hyperbola function? G of x is equal to 3 over x minus 1. What type of function is this, guys? This one specifically. We'll come also in the comment section and saying exponential. Do we all agree that this is exponential? Is it, guys? Okay. Guys, this is not exponential. This is a hyperbolic function. It's a hyperbola. Hyperbola, right? So this is a hyperbola function. Okay, yeah, also sometimes referred to as a rational function. Okay, so this is a hyperbola function. Please, guys, let's not run into the risk of not knowing the type of function we have there. It's a hyperbola function because hyperbola functions are in the form y is equal to a over x plus q. Let's not forget that. So this is a hyperbola function. The variable x is in the denominator of a fraction, okay, and it's raised to the power 1. So this is a hyperbola function. Plus q, all right, so that would be hyperbola. This here is exponential. F of x is equal to 3 to the power. You see the variable, it's an exponent, okay, and we were able to change the form from 3 to the power negative 1 to 1 over 3 to the power x. All right, so let's look at a particular question here. Okay, so like I said, this is grade 10. This is grade 10 functions. Okay, so the first question says sketch the graphs of f and g on the same set of axes. Indicate the intercepts with the axes and the asymptotes. Show at least one point on each branch of g. Okay, so let us draw our Cartesian plane. All right, first and foremost, always draw in the Cartesian plane, very importantly. All right, and then remember, for an exponential function, this is f of x is equal to 1 over 3 to the power x minus 3. So for that function, we must first do what? We must first check what is the a value, what is the b value. Okay, our a value here is positive 1. Our b value here is 1 over 3. And then the exponent x is the variable minus 3. So this exponential function has an a value, okay, because for each function I like planning, making sure that we have a plan in place. So step number 1, you look at the function. You can see here there's a number here, 1. You cannot see it, but it's multiplied to this 1 over 3, which is the b value, and it's raised to the power x. So our a value here is 1. So a is greater than 0. That means our function will be found above the asymptote. Okay. Remember, whenever a is greater than 0 for an exponential function, okay, in this case it is 1, Okay, like I said, guys, there's a 1 that's here. You can't see it, but it's there. It's there, right? Even if it's not written down, it's there. Okay. The invisible number that's before 1 over 3 is 1. Okay, so that's why we say a is equal to 1. It's greater than 0, which means the function will be found above the asymptote. That's what we know whenever a is greater than 0. Okay, our b value is between 0 and 1. Okay, our b value is 1 over 3. There it is. That's our b value. It's 1 over 3. Okay, so in my head, I already have an idea of the image of this function, that this function will be lying above the asymptote. Okay, and because of the fact that a is greater than 0, a is greater than 0, okay, and 2, b is between 0 and 1. Because of these two beautiful conditions, I know that my function will be above the asymptote, but it will be a decreasing function. Okay, so that is the shape I am expecting that the function will have. Okay, so very importantly, this here before 1 over 3 is my a value, and the a value, if it's greater than 0, means that the function is above the asymptote. B, on the other hand, if it's between 0 and 1, then b here in this case is 1 over 3. It means that the function will be it will be a decreasing function above the asymptote. Okay, and that's very important. So that's 1. 2, what is the asymptote of the function? Okay, so for a exponential function, we always have one asymptote, and that is the horizontal asymptote. So our horizontal asymptote is given by our q value. Our q value is the constant value of the function. So the constant value here is -3. This term, that's a number that's standing alone without a variable, we call that our q value. It is our asymptote. Okay, so that means y is equal to -3 is the equation of the horizontal asymptote for this exponential function. Okay, right, so very importantly, let me just rewrite here so that we can all appreciate that this is the form of any exponential function. A, which is 1 here, b, which is 1 over 3 here, to the power x, plus q, which is -3 here. So like I said, a, when it's greater than 0, means that the function is found above the asymptote. Okay, I repeat, when a is greater than 0, which in this case it's equal to 1, it means that the function will be found above the asymptote. B, on the other hand, b is 1 over 3. So 1 over 3 is a value that is between 0 and 1. So whenever that value b is between 0 and 1, which in this case b is equal to 1 over 3, we know that as the function is above the asymptote because of a, simultaneously because b is between 0 and 1, because it's 1 over 3, it means that the function will be a decreasing function. So the shape of the function, I already in my head have an idea of what the shape of the function will be. It will be a decreasing function like this above the asymptote. This here, guys, is like a rough line that represents the asymptote. Okay, now let's go here. Part number 2 of when we are planning to sketch the function is being able to recognize or indicate what is the asymptote. Guys, remember, by definition, an asymptote is a boundary line where the function that we are sketching is not defined. I repeat, an asymptote is a boundary line where the given function does not exist. KK, you can ask. Yeah, you can ask. You can even request as a guest if you want, and you can ask questions that you want. Please go ahead, be my guest. So asymptote, all right, is that boundary line. What is that boundary line? If you go to the form of the exponential function, remember the a we've already spoken about. This is grade 10. The b we have spoken about. Okay, now we are at the q value. This q value, which in this case is -3, tells us what the asymptote is. The asymptote is defined by the q value, and specifically we are speaking here about the h asymptote. In other words, the horizontal asymptote. That's what we are referring to here. Do you need help with grade 9, KK? Is that why you're asking me here? I do grade 9 sometimes, but it's just that at this point in time, I'm just going through some grade 10 content. So grade 9, definitely. I do grade 9 sometimes. Okay, so horizontal asymptote is given by the equation y is equal to -3. Okay, that's very important. Then 3. We are going to now find the x-intercept and the y-intercept. Now, what is the x-intercept? The x-intercept is where the function cuts the x-axis. That's where we let y be equal to 0. That's the x-intercept. Okay. The x-intercept, we let y be equal to 0. The y-intercept, we let x be equal to 0. That's where the graph cuts the y-axis. Okay, so two important things here. X-intercept, that's where the graph cuts the x-axis. We let y be equal to 0. The y-intercept, that's where the graph cuts the y-axis. We let x be equal to 0. So we're going to quickly go ahead and check. When we let y be equal to 0 in this particular function, what do we get as our corresponding x value? Okay, KK, that's fine. You're writing math at the 19th of June. Okay, that's fine. So we want to have a revision session one of these days, one of these times. Okay, hopefully you followed me first and foremost, and that's number 1. 2, all right, when preferably would you like to have that session? We can have a revision session for grade 9s, definitely. Okay, you can revise the term 1 work and everything. Okay, and then we can take it from there. Maybe you can send me an inbox or a message just in the inbox and tell me when preferably would you like to have that session happen. You know, what day, what would you like covered? Konnichiwa Kenzie. You can let me know, and then I'll definitely follow through in the appropriate time. Wow. Okay, x-intercept, let y be equal to 0. So let's go to the function. There it is. Okay, let's let y be equal to 0 there. Okay, so let's rewrite the function. The function is f of x. I'm writing 9th June. What are you writing 9th June? What grade? What maths? Yeah, inbox, guys, inbox. With your specific details and when preferably would you like to have a selection. So f of x is equal to 3 to the power negative x minus 3. Okay, so let's let y be equal to 0. Remember, f of x is y. Okay, so we can simply let what? We can let y be equal to 0. Replace with y, replace 0 in the place of y. Then we solve this equation. Transpose the -3, we get 3 is equal to 3 to the power negative x. Remember, guys, when -3 gets transposed to the right hand side, it simply changes the sign. So from -3 it becomes +3. The bases are the same. This is an exponential equation. When the bases are the same, what do we do? Remember, the exponent here that we don't see is 1. So what do? We drop the bases and we equate the exponent. So we have 1 is equal to -x. Therefore, then we divide both sides by what? By -1, which gives us x is equal to -1. So when we let y be equal to 0, guys, in the place of y, we write 0 equal to 3 to the power -x minus 3. 0 is equal to 3 to the power negative x minus 3. We transpose the minus 3. This minus 3, because it's a second term, we transpose it. It becomes what? Positive 3 on the left-hand side. Then after that, we can see that the bases are the same, base 3, base 3. So what do? We drop the bases. So these 3 and this 3, they disappear. We get left with 1 and negative x, because there's a property where equations of exponents are concerned that if the bases are the same on either side, we can simply drop the bases and equate the exponents. So we have negative x is equal to 1. Therefore, when we simplify further, we use the multiplicative inverse. We divide both sides by negative 1. Since the coefficient of x is negative, we divide by negative 1 on the left and the right. And then that leads us to x is equal to negative 1. So that means our coordinates for the what? The x-intercept, when we let y be equal to 0, the coordinates are negative 1 in the place of x, and what? And 0 in the place of y. So this is our x-coordinate and our y-coordinate. Okay, so this, guys, is our x-intercept. These are the coordinates of the x-intercept. X is equal to negative 1 is the x-intercept, the way the graph cuts the y-axis. The x-axis, sorry. Okay, let's go to the y-intercept. Let's let x be equal to 0 this time round. Okay, remember the function is f of x is equal to 3 to the power negative x minus 3. Okay. Then we let x be equal to 0, which means f of 0 is equal to 3 to the power negative 0 minus 3. Now a negative times 0 gives us 0. And we know that 3 raised to the power 0 is actually equal to 1. And then 1 minus 3 gives us negative 2. So when x is equal to 0, we get an output value of negative 2. So what does that mean? The coordinates for the y-intercept, when we have let x be equal to 0, when in place of x we substitute 0, when 0 is replaced with our x, we get 3 to the power 0 minus 3. 3 to the power 0 is 1. Remember from the definitions of exponents, any base raised to the power 0 is equal to 1. In this case, when 3 is raised to the power 0 is 1. 1 minus 3 gives us negative 2. And that means when we substitute x, which is 0, we get an output value of negative 2. So these are our coordinates, 0 and negative 2. Done. So we have two of the points, x-intercept and y-intercept. I think now we are ready to sketch. So when we are ready now to sketch this function, f of x is equal to 3 to the power negative x minus 3, the first thing we do is we go and indicate where the asymptote is. Y is equal to negative 3. So let's just come here. Let's say this is negative 3. So that means we just draw a horizontal line. Then we mark it and label it. Using our ruler, guys, we draw that horizontal line. I'm just holding a phone with my other hand, so that's why I can't place the ruler and draw the spaced out horizontal line that you see there. So this is my asymptote, and it's y is equal to, negative 3, not 1, negative 1, negative 3. As you can see, this was my q value. This is the horizontal asymptote that I had actually indicated is the horizontal asymptote, represented by the value of q there. Okay, horizontal asymptote drawn in. Secondly, I go and check my intercepts. Remember the coordinates I got? When I substituted y being 0, I got a corresponding x value, which is negative 1, and those are my coordinates. So negative 1 and 0. Where is negative 1 and 0? Where x is negative 1 and y is 0. Where is that on the Cartesian plane? This is grade 10, guys. Where x is negative 1. Okay, let's go. This is negative 1 this side. Okay. So let's mark negative 1 and 0. It's on the x-axis, negative 1. All right. So that point negative 1 and 0 has been marked, okay, where x is negative 1. Remember guys, on the Cartesian plane, the x-axis, my x values on this side of the Cartesian plane are negative. Okay, then here I have 0, which is at the origin, and then on this side of the Cartesian plane, my x values are positive. So I have positive x values this side, I have negative x values on this side. So let me just say negative 1, negative 2, negative 3, just so that we can reveal some values of what? Of x. Okay, then let's reveal some x values that are positive on this side. We have 1, we have 2, we have 3. All right, and I mean we can represent a whole lot more. Okay, then let's reveal some y values here that are negative. We have negative 1, negative 2, negative 3. And then here at the top we have 1, 2, 3, 1, 2, 3. I mean, obviously we can represent more, but I hope you guys get the point. Okay, so that's our point, negative 1 and 0. There it is. We've marked it. Let's mark the other point. Remember, we also found the y-intercept when we let x be equal to 0. You see, that's when we substituted x as 0. We got the corresponding y value, which is negative 2. And then these are our coordinates, 0 and negative 2. When x is 0, y is negative 2. Now let's go and locate. Where is y negative 2? That's here. But where is x 0 at the same time? It's on the y-axis. Okay. So you can see, guys, remember when I said based on a being positive, all right, and b being between 0 and 1, this would be the shape. This was like in my plan. So do you see now? Look at this. You see? So I see the shape, and I'm going to basically draw it in accordance to what I see. All right. So there's the exponential function. You see? It's like a nice curve. Passes through negative 1 and 0, passes through 0 and negative 2, and then it curves, approaches the asymptote, but never touches this asymptote. Very important. This exponential function can never touch this line because it's the asymptote, and the function is never defined on the horizontal asymptote. Very important. So there we have it. That's the function, guys. Very straightforward. Do you see? I hope you guys can see that. Okay. Now, we were also told, all right, and I'm just going to do this in separate axes. We're also told to sketch the function g of x is equal to 3 over x minus 1. All right, so I'm just going to go over what we need to take into consideration when we sketch this function. So it comes with some planning, and I love the planning, guys. You know, they usually say a goal without a plan is a wish. So if I have a plan in place, I can carry it out and it can come to fruition. So let's start there. First step, we go and look at the function. We have g of x is equal to 3 over x minus 1. This is a hyperbola. So in our head, we know what we are dealing with. We know what shape and what form the function should take. So the general form of a hyperbola is a over x plus 2. The a value here in this case is positive 3 over x minus 1. So this positive 3, take note of it, positive 3. So in other words, a is equal to 3 for our hyperbola function. What does that mean? It means a is greater than 0. What does it directly mean when a is greater than 0 for a hyperbola function? Okay, it means that when we sketch the function, okay, we know that for this function we have the horizontal asymptote and the vertical asymptote. This vertical asymptote in grade 10 is always the y-axis. It will be the equation x is equal to 0. As for the horizontal asymptote, we are going to look at that shortly. Just bear with me though. So a, the numerator value for the fraction is 3 over what? Over x. So a is equal to 3. meaning a is greater than 0. That tells us in which quadrants the function will exist. So we know that the function will exist in the odd number quadrants. In other words, in quadrant 1 and 3. Now, someone will be asking, what is quadrant 1 and 3? Guys, when you have your asymptotes drawn in your Cartesian plane, quadrant 1, 2, 3, and 4 are marked according to the asymptotes. The horizontal and the vertical asymptote mark off the quadrants that we have for the function. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And why do we say this is quadrant 1? It's because the asymptotes define the boundaries of my quadrants. Okay, so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So whenever A is equal to 3, or in other words, whenever A is greater than 0, A is positive, then that means that our function, that is our hyperbola, okay, is found in the first and the third quadrant. That's why I say the odd number quadrants. That's when A is positive. Okay, and maybe someone is sitting there and asking, what if A is negative then, sir? When A is negative, it means that it's not found in the odd number quadrants, but it's found in the even number quadrants. In other words, quadrant 2 and 4, if A was less than 0. So in this situation, A is positive. It's 3. It's greater than 0. So we expect in my plan, roughly speaking, okay, because this guy is just rough, I know I'm expecting to find or have a function that is like this, right? This is still me planning, okay? Because I'm looking at the function, I'm like, okay, numerator value is 3. It is positive. This positive numerator value means that the a value for my hyperbola function is positive. So if my a value is positive, it means that my function is found in the first and third quadrant, according to the what? To the asymptotes. The asymptotes show me the quadrants. Okay, so that's why I need to make sure my asymptotes are clearly stated and are there. Okay, 2. Now I need to indicate what the vertical asymptote and the horizontal asymptote are, the equations of the asymptotes. Okay, for my hyperbola function. Okay, so for this function, okay, 3 over x minus 1. All right, you can clearly see, guys, that the vertical asymptote, as I told you, if you look at the denominator, we have a isolated variable x, and the question is, what value of x would make this fraction undefined? If x is equal to what would the fraction be undefined? Okay. It would be when x is equal to, and you've got it right, when x is equal to 0. So our vertical asymptote for this particular hyperbola is x is equal to 0. All right. Then lastly, horizontal asymptote, where the function is not defined horizontally. Okay, it is when y is equal to, now check, what is the q value of the function? The q value of the function, guys, is actually -1. The q value is -1. So therefore we say the horizontal asymptote is y is equal to -1. So in our grade 10 context, these are the 2 asymptotes that we have for our hyperbola. All right, and that's very, very important to note. Okay, then number 3, we then need to find the x-intercept. We know that's when we let y be equal to 0. All right, but we are not going to waste our time and find the y-intercept. Why? Because we can see that in this case, because we are still in grade 10, our hyperbola function has a restrictive measure in place, which is the vertical asymptote, and it's on the line x is equal to 0. So if I was to find the y-intercept, I would actually see that I do not actually find a specific value because the function is not defined along this line, x is equal to 0. So we don't bother ourselves finding the y-intercept within the grade 10 context. Please understand, guys, these are grade 10 hyperbola, right? We have limitations in the hyperbola functions in grade 10. Okay, so we are just going to let y be equal to 0 in our function and then find the corresponding x value. So let's do it. 0 is equal to 3 over x minus 1. Pretty straightforward. You transpose the negative 1, we get 1 is equal to 3 over x. And then all we do is we cross multiply. We do what? We cross multiply. Cross. All right. In other words, the LCD, okay, which the concept is finding the LCD, which is x. Our restriction is that x cannot be 0 because obviously x cannot be 0. Then we multiply by the LCD left and right. We multiply in the numerator by x. Okay, and what does that lead us to? It leads us to x is equal to 3. Okay, we multiply by the LCD both sides. We multiply all terms by the LCD in the numerator. This x and this x cancel. We're left with 1 and 1. That's 3 times 1, which is 3. Then x times 1 on the left-hand side gives us x. So therefore, that means our x-intercept is 3 and 0. Okay, guys, and that's it. Our planning has been successful. We were able to figure out what the a value, the numerator value, helps us, what it helps us with regards to the function, the defining of quadrants and where the function is found. Okay, then the fact that when a is positive, odd number quadrants, meaning first and third quadrant if a is positive. But remember, if a was negative, we would talk about the even number quadrants, and those are according to the what? Those are according to the asymptotes. When our horizontal and vertical asymptote are in place, we can talk about first, second, third, and fourth quadrant. Then we must find our vertical asymptote and horizontal asymptote. So for grade 10, as I said, our vertical asymptote is always x is equal to 0 in grade 10 because of the limited variable x, which is alone in the denominator. Grade 11, it's a different story because you have a binomial expression in the denominator, and obviously that would mean that it's not just only x, but it's other values of x that are possible for our vertical asymptote. Our horizontal asymptote, the q value, which is y is equal to -1. There we have it. Then we can find our x-intercept by letting y be equal to 0. And someone will be like, why can't we find our y-intercept? We can't, because remember, x is equal to 0 is an asymptote, which means it's a boundary line where the function does not exist. So we don't bother ourselves by finding the y-intercept. We just end there by finding the x-intercept. And all we did there is we substituted y is equal to 0 where y is supposed to be, transpose the -1, then we multiply both sides by the LCD, okay, and we get x is equal to 3, right, which is not x is equal to 0, which is great. So it means our coordinates for the x-intercept are 3 and 0. Now we are ready to sketch, so let's go and sketch. First things first, let's sketch in our asymptotes. Guys, for the exponential function and the hyperbola, it's important that after planning, you then sketch in your asymptotes. So we know that the hyperbola has 2 asymptotes. The first asymptote is the y-axis, and it has the equation x is equal to 0. So I just label that y-axis and label it as x is equal to 0. Then the horizontal asymptote, what was it? It was y is equal to -1. Where did I get that? It is the constant value, my q value. That gives me the equation of the horizontal asymptote. So that's why we say y is equal to -1. So let's sketch that in. Y is equal to -1. Okay, so you use your beautiful ruler, okay, so that the line is really straight, and you leave spaces in between the lines, all right, so that you can make sure to indicate that it's a asymptote and it's a horizontal one. Okay, and this is -1, guys. Okay, my horizontal asymptote. Now that my asymptotes are in place, I can clearly see my quadrants. This is my first quadrant all the way, the first quadrant to the asymptote. This is my second quadrant. This is my third quadrant. This is my fourth quadrant. You see, because the asymptotes, they basically define the boundaries of the quadrants. Then let's go and sketch our point, the only point that we were able to find when we found the x-intercept, which is 3 and 0. So let's go to my Cartesian plane where x is 3. So that means 1, 2, we know 3 is somewhere there, right? And the y value at the same time must be 0. So that is on the x-axis. That's where the function will be located, right? Now, someone will be like, okay, sir, I know that I'm supposed to have the function in the first and the third quadrant. So this point is definitely in the first quadrant. But sir, I don't have any points so that I can draw my graph in the second quadrant. Let alone another point at least, sir, in the first quadrant so that I can see the shape of the function in the first quadrant. So what we do here to do damage control, and I call this damage control because it is, all right, is that because of the limited number of points that we have, let us go and find some arbitrary points using our function. So let's see here. We know that let's try and find another random point here. So let's take x is equal to 1 and go and substitute to the place of x so that we can see what is this point. You can use it to quickly get these and then be able to locate for the first quadrant and also subsequent points for the other quadrant, so that we can actually at least indicate where the function exists in that quadrant. Okay, so let's check when x is equal to 1. If I substitute 1 here in the place of x, that means I'm going to get 3 over 1 minus 1. Y is equal to 3 over 1 minus 1. 3 divided by 1 is 3. 3 minus 1 is equal to 2. So my coordinates, right, guys, I don't even have to even write this down. I'm just writing it down so that you can understand what I'm doing. If we let x be 1, we get a corresponding y value of 2. So when x is 1, y is 2. Let's go to our Cartesian plane. X is 1. Okay, let's go and put in there our y values, 1, 2, at least 3. So let's go when x is 1, y is 2. Where are we meeting? We are meeting there, right? 1 goes on a date with 2. And where do they meet? At the restaurant, which is there. That's the restaurant. Okay, seems like they're eating at a very nice restaurant, if you ask me. Okay, so I'm sure you guys can see what's going to be happening here, right? You see? Yeah. So if you were to actually draw the curve, okay, you can see, you see, nice smooth curve there, nice smooth curve. And what's beautiful is that when you are able to have at least 2 points in one quadrant, you are able to see the shape nicely. All right, so I'm just gonna mark that as 1 and 2. Okay, when x is equal to 1, y is 2. That is the point. 1 went on a date to Spur. That's where they met at Spur. 1 went on a date with 2 and they met at Spur. And in that meeting, they had a great time. Okay, so that is the point where they meet. All right, 1 and 2 is exactly there. All right, and then 3 and 0. X is equal to 3. Y is equal to 0. It's exactly on the x-axis. Okay, on the x-axis, y is 0. So that's why 3 and 0, we are meeting at the y-axis. Okay, yeah, 3 is meeting a 0 at her place. Okay, so that's basically that point. Okay, all right. So now remember, there's supposed to be a arm in the third quadrant. So the first quadrant is sorted. Now we need an arm in the third quadrant. So what we do is we find some arbitrary points. Let's say -1, and let's check -2. Okay, since they are following each other. So -1, -2. Let's take -1. We do the same thing. Go substitute it into the function. 3 divided by -1 gives us -3. -3 minus 1 gives us -4. So when x is -1, y is -4. Now the question is, where is -4 located? So let's just make sure our Cartesian plane, we just extend it a little bit there. And then let's try and locate -4. Let's say -4 is there. So when x is -1, y is -4, where are we meeting? Where are we meeting? We are meeting here. Right? Yeah. Then let's check x is -2. Same thing. You can take -2, substitute it, use your calculator even. 3 divided by -2 minus 1. All right, guys, your calculator will be super fast to use, okay, if you use it. All right, so yeah, -3 minus 2 over 2, we get -5 over 2, which is actually -5 over 2 is actually -2,5. Okay, and -2,5, if we have -2 then followed by -3, remember -2 and -3, midway between -2 and -3, that's where -2,5 would be. So -2 and -2,5, where are they meeting? They're meeting there. Okay, midway. Okay, and then you just write with your pencil, just insert there so that they know it's -5 over 2 with -2. All right. Okay, and guys, what do you then do when you are sketching? Okay, remember that was your asymptote. All you simply do is you connect these two and you curve. You curve. Okay, you curve. Do you guys see this? See, look, there we have it. That's my hyperbola. And at least I have some points, -2 and -5 over 2 for this point. And then here I have -1 and -4, just so that I can label those points, guys. And there we have it. Sketch finished. Okay, right, my exponential function done and dusted. Nicely done. Okay, and I can label it, that's f of x, and then here I can label it, that's g of x. That's g of x. Okay, all right, so hopefully you guys see how we sketch these functions, how we are able to sketch these functions, right? Straightforward to the point. Any questions? Anyone with a pressing question? Any concerns? Anything you'd like to clarify? Anything at all when it comes to sketching you see, I sketched an exponential function, and then I sketched an exponential function, and then I sketched a hyperbola function for my grade 10s. CJ, logs, no, I'm not doing logs. This is not grade 12, it's grade 11. Okay, but I mean with logs, if you CJ, obviously you would know that as someone who's in that grade, you know that logs, those are inverse functions for exponential functions, so that's fine. And not that guy, remember, I'll be uploading this. So yes, it's been on a bit, so yeah. Write down the equation of the axis of symmetry. Write down the equation of the axes of symmetry. The equation of the axes of symmetry. So it's not just axis of symmetry, axes of symmetry. Okay, so they're saying write down the equation of the axes of symmetry. No problem, Seth. Let me know in the comment section when you'd like me. I mean, not in the comment section, but you can inbox me, follow me and inbox, and just let me know when you'd like me to do some grade 8 work, and then I can arrange a date to do that, and then yeah, I'll let you in on that specific time. Write down the equation of the axes of symmetry. Okay, write down the equation of the axis of symmetry of G. Okay, so G of X here, guys, does have what we call an axis of symmetry. Okay, and there are two of them. That's why, for instance, you see here they have the plural word axes, not axis, but axes, meaning there are multiple, not just one. Okay, this is plural. Write down the equation of the axis of symmetry. Okay, so there are two of them. All right, there is a positive gradient axis of symmetry. Okay, and there's a negative one gradient of axis of symmetry. Yes. Okay, and the reason why we say that is because here's the deal. Okay, so the vertical and the horizontal asymptote, okay, they actually intersect exactly where the positive gradient axis of symmetry, okay, let me just roughly draw that, and the negative gradient axis of symmetry. Where those two lines intersect is exactly at the point of intersection of the horizontal asymptote and the vertical asymptote. Okay, and the way I make it easy for learners to be able to write, right? Remember, guys, that in order to get the equation of a straight line, you need two things. You need a gradient and a point. So for the positive gradient of axis of symmetry, in high school, grade 10, 11, and 12, the positive gradient axis of symmetry will always be positive 1. And I'm going to write always, right? Due to our limitations within the syllabus. So M will always be 1 for the positive gradient axis of symmetry. Then for the negative gradient of the axis of symmetry, the gradient will always be negative 1. So I'm going to highlight or circle this word always. So one thing for sure you guys should always have is the gradient. You should know what the gradient of the positive axis of symmetry will be. It will be positive 1. The gradient of the negative axis of symmetry will be negative 1. And that is always grade 10, 11, 12. So you never have to think about what is the gradient of this particular line, because it will always be, for the positive gradient axis of symmetry, it will always be positive 1, and for the negative gradient axis of symmetry, it will always be negative 1. Now the next thing now we want to think about is, all right, WWJD indicated in the comment section, is the axis of symmetry dependent on the asymptote of the hyperbola? And I said yes. How so? Well, the horizontal asymptote and the vertical asymptote, where those two intersect, is also the point of intersection of the axis of symmetries, both the positive gradient axis of symmetry and the axis of symmetry and the negative gradient axis of symmetry. Okay, and you can see, guys, that the symmetrical line, what it does is it actually divides this function into mirror images of each other. You can see a mirror image of the function this side and that side. If you look at this negative gradient axis of symmetry, you can see the mirror image of the function on this side, the mirror image on that side. So hopefully you guys understand why it is that we say this is an axis of symmetry. Okay, the axis of symmetry, mirror image this side, mirror image this side. That's the negative gradient axis of symmetry. The positive gradient axis of symmetry, mirror image on this side, mirror image on this side. So there's the formation of the mirror image of each function because of the axis of symmetry. Okay, very, very important. So like I said, your positive gradient x of symmetry will always be positive 1. Your gradient of the axis of symmetry that is negative will have a gradient of negative 1. Okay, so all you just do, guys, there's a template for this function when you are writing the axis of symmetry, and the template is simply this. Please, guys, make life easy for yourself. Don't complicate life. Yep. Okay. Alright, so here's the template, guys. This is the template, okay? The equation of the axis of symmetry. If you have this template, y is equal to a into x minus p plus q. Okay, the a place is for the gradient. Okay, the p place, all right, for grade 10, it's always going to be 0. And then the q place is just the q of the hyperbola because it represents the horizontal asymptote. Okay, so this is the template I'm talking about. So we want the gradients of, okay, so I'm just going to use that template then. Okay, very, very simply put, I'm going to use that template. So remember, for the positive gradient axis of symmetry, what did I say? I said the gradient will be positive 1. It will always be positive 1. Okay, grade 10, 11, and 12, guys, they will always be positive 1. So here, all right, that's what I'm going to write. I'm going to write y is equal to, in the place of a, I'm going to write positive 1. Then in brackets, x, we write x. Now, because our vertical asymptote in grade 10 is 0, the vertical asymptote is x is equal to 0. In the place of p, we write 0. That's why. Okay, so WWJD in the comment section earlier on said, is the axis of symmetry dependent on the asymptote of the hyperbola? And the answer is yes. I've just pinned the comment. Okay, so the vertical asymptote, which is 0, replaces the letter p, and then the horizontal asymptote, the value of q, remember what was the value of q? Here it's negative 1. So that means the value of q, we're going to write there in the place of plus q, we're going to write negative 1. Okay, and then we are going to take this one and distribute it inside the bracket. Okay, remember, this is 1. X minus 0 is what? It's x. Okay, 1 times x is x minus 1. And there it is, guys. Y is equal to x minus 1. This is the equation. The positive gradient axis of symmetry, the equation of that axis of symmetry is y is equal to x minus 1. That's the positive gradient axis of symmetry. Done, finished, dusted. Not a problem. So I'm going to repeat the template. Y is equal to a into x minus p plus q is what we need to utilize when we write the equation, if we want to just simplify life for ourselves. All right, I'm going to also do the second way in which we can get the equation so that you guys can understand that either way. All right, because some of you may be taught differently. So I like using the template because this template can be used in grade 10, can be used in grade 11, can be used in grade 12. All right, and so as I said, the p-value simply indicates the value of the vertical asymptote. The q-value simply indicates the value of the horizontal asymptote. So our vertical asymptote was 0, so we substitute 0 there, x minus 0. Our horizontal asymptote was q. So in the place of q, we substitute -1. Okay. And then remember, I said the gradient, the a value gradient, since it's the positive gradient, okay, the positive gradient is 1. Okay, right. So that's just one way of writing our positive gradient axis of symmetry. But I also want to suggest that axis of symmetry by using what we know. Okay, so since it's a straight line, so first and foremost, let's come here. Y is equal to ax plus q. We know that a stands for gradient. Now, since we are talking about the positive gradient axis of symmetry, remember what did we say? The gradient, in this case, since it's a positive gradient, it will always be +1. So what we do is we say y is equal to 1x plus q. Now, what is left, guys? What is left is we need to find the value of q. Q, in this case, is the y-intercept, right? So in grade 10, what's nice is that you will forever have the axis of symmetry. Okay. In grade 10, you'll forever have the axis of symmetry cut through, guys. It will always, in grade 10, the axis of symmetry, both of your axes of symmetry will always be cutting through your y-axis, your y-intercept, right? In grade 10. So that's what's beautiful then, is that you will know, okay, that this horizontal asymptote gives you the value of q. So let's come over here. What do you guys see? Y is equal to x. Now in the place of q, what are you going to write? -1. And there it is. Done. So this is your positive gradient axis of symmetry. Okay. This is your positive gradient axis of symmetry. So this was the template approach, where you use y is equal to a into x minus p plus q. You can utilize that, like I said. The p value represents the vertical asymptote. Our vertical asymptote for this particular function in grade 10, remember, is always x is equal to 0. So that's why I was saying the p value gets substituted with 0. That's why we had 0 there. Then q is substituted with the horizontal asymptote, the value of the horizontal asymptote. So we go there. The value of the horizontal asymptote for our hyperbola was -1. So we come here and we substitute -1. And then what's x minus 0? It's x. What's 1 times x? It's x. Then the -1 is just going to become the second term in the equation. So the equation of the positive gradient axis of symmetry is y is equal to x minus 1. Clear. Or alternatively, you could use the form of the straight line function. Whenever you want to find a straight line function, you need two things. You need the gradient, which I've always told you that if it's the positive gradient axis of symmetry, then obviously the gradient will be +1. So in the place of a, I substitute 1. Then 2, you want the y-intercept of that particular straight line. You want the y-intercept of that particular straight line. So what is the y-intercept of this axis of symmetry? Guys, I indicated here that the axis of symmetry will always pass through in grade 10. It will pass through where the vertical asymptote and the horizontal asymptote intersect. Okay, and this point here, right, is actually the point of intersection of the vertical asymptote and the horizontal asymptote. So it's on the y-axis. It is always going to be on the y-axis in grade 10. And therefore, the q value of the hyperbola, which is the horizontal asymptote value, will be the q value of the axis of symmetry. So in the place of q, since q was -1 for the for the hyperbola, q is going to be -1 for the hyperbola in the 10th grade. Okay, so hopefully it makes sense. All right. Anonymous ZA, I am from an anonymous place in South Africa. So I love your name because it basically it captures the essence of why I have a working name such as this, Maths is a Game, and that's why I'm utilizing it in the platform to teach rather than me. I don't want this to be about me. It must be about the gamers. Okay, all right. So hopefully we all are together here. Now let's go and look at the negative gradient axis of symmetry. The negative gradient axis of symmetry. Yes, indeed I do. Yes, indeed. And suspending of the account. Okay, so negative gradient axis of symmetry. If we'll use the template, let's go use the template because the template here is still relevant. Okay, negative gradient of axis of symmetry. Remember that the gradient here is going to be -1. Okay, the gradient is going to be -1. So let's rewrite then -1 into x. Now the p-value, what did I say the p-value? It is the value of the vertical asymptote. So it's x minus 0 still. The q-value, it is the value of the horizontal asymptote. And the horizontal asymptote was what there? -1. Hi guys, surely we are seeing this now. Then x minus 0, that's x. You multiply that with -1 minus 1. So the final answer is -x minus 1. This here, guys, is the equation of the negative gradient axis of symmetry. The gradient is -1 as it ought to be. And then obviously the y-intercept of the negative gradient axis of symmetry is also the horizontal asymptote of the hyperbola, because basically that's where the two meet. All right, so there it is. Y is equal to -x minus 1. Okay, surely guys, that was not too painful. I hope. Hopefully it was not too painful, but it was okay, not too shabby, not too dabby. I want us to check something else that's quite interesting here. Look at this. This question says, for each of the following conditions, draw a rough sketched graph on the axes provided in Annexure A. Now, I don't have Annexure A. So let's just look at how this will be. Let's use this. So look at this. 4.1, it says f of x is equal to mx plus c. Okay, what type of function is this form giving us, guys? Straight line or linear, hyperbola, parabola or quadratic, or exponential? Which one? Quartile, c squared plus c squared plus c squared is equal to 3c squared. C squared plus c squared plus 6 squared. We call these like terms. These are like terms. Why do we call them like terms? It's because the variable, each term of the expression has the same variable and it's raised to the same exponent. So we call these like terms. And we can add like terms. But how do we go about adding like terms or subtracting like terms? What we do when we are adding and subtracting like terms is we keep the variable or the letter and its exponent. Then all we do is we add the coefficients, meaning the numbers before each variable. So we'd say 1 plus 1 plus 1 gives you 3. 3 what? 3c squares. Okay. This is like saying orange plus orange plus orange. You would say your answer is 3. oranges. Are you with me? So basically, like terms, it's like you are using the same thing and you are adding it together. So hopefully that makes sense. Anyways, let's come back here. Guys, f of x is equal to mx plus c, where m is greater than 0 and c is less than 0. What do we understand here? F of x is equal to mx plus c. You're welcome, Cartel. F of x is equal to mx plus c, where m greater than 0 and c less than 0. What is this function? What type of function is this? Options: linear, straight line, 1. 2. Parabola, quadratic, 3. Hyperbola, 4. Exponential. Which one? Which function? What type of function is this? Straight line, linear, that's your first option. 2. Parabola or quadratic. 3. Exponential function. 4. Hyperbola. Which one is it? Mornay Sabah is saying straight line. Nuri is saying straight line. Okay, straight line, straight line, straight line, straight line. Seems like straight line wins the day. Straight line. Wow, Mornay Sabah is like saying straight line even with some exclamation. All right, okay. No, that's great. I think we have got a winner there with Mornay and Nuri. Yes, guys, this is a straight line function. The form of a straight line function is mx plus c. Remember this m and this c. All right, m stands for gradient. C is the y-intercept. M stands for gradient. C is the y-intercept, where the graph cuts the y-axis. Now, guys, please take note. It says we need to sketch a rough graph of f of x is equal to mx plus c, where thank you for the Afrikaans. I see. We've got an Afrikaans translator. Mornay, I think I need to utilize you in my live sessions. You can translate for me for my Afrikaans viewers there. Thank you so much for that. F of x is equal to mx plus c, where m is greater than 0 and c is less. So let's take into consideration a few things. M greater than 0, right? What type of shape are we looking at here? Are we looking at a shape like this? Because there's 4 types of shapes we can have. Shape like this, shape like that, shape like this, or shape like that. Option 1, option 2, option 3, or option 4. Which shape are we looking at? What kind of straight line are we looking at? Are we looking at a straight line like this? A straight line like that, a straight line that's horizontal, or a straight line that is vertical? Okay, which one? 1, 2, 3, 4. Which one? Okay, Nuri says 2. Okay, so Nuri is saying this one. Okay, I'm not going to confirm it yet. Let's see what other amazing viewers have to say about when m is greater than 0. Remember, this is saying that the gradient is positive. When the gradient is positive, is it a straight line that is looking like that? Is it a straight line looking like that? Is it a horizontal straight line, or is it a vertical straight line? Which one is it? So Nuri is saying it is number option 2. So meaning this is an increasing straight line. Okay, and I agree 100% with Nuri that yes, when m is positive, or when the gradient is positive, it's an increasing straight line. In other words, as x increases, okay, because this straight line suggests that as x increases, remember x increases from left to right, we are moving in this direction, then y also does what? Increases from the bottom to the top. So that's what's happening with this function. As x increases, y also increases. So as x increases, y increases as we grow, as we basically go in this direction. This is a positive gradient straight line. So when m is positive, guys, that is the shape that we are expecting to draw for our function. Secondly, c is less than 0. What does this mean? C is less than 0. Do you remember what we said C represents? Okay. Do Do you remember, guys, what we said C represents? Because we said M represents gradient, all right? And it has to do with the direction and the shape of our function. C less than 0. Yes, Nuri, 100%. C basically stands for our y-intercept. In other words, this is where the graph cuts the y-axis. So there are two places we can cut the y-axis. We can either cut the y-axis where the values of y are positive, or we can cut the y-axis where the values of y are negative. So here they are saying C is less than 0. What does that suggest? Are we cutting place? Where are we cutting it? Since C is less than 0. Are we cutting it above the x-axis, or are we cutting it below the x-axis? Where are we cutting the function on the y-axis? Where exactly? Since C is less than 0. Okay, Nuri is saying below the x-axis, right? Okay, remember, guys, that the values of y below the x-axis are negative. Okay, yeah. So if C is less than 0, that means the graph will cut the y-axis where the values of y are negative. I repeat, if C is less than 0, it means that our y-intercept, where the graph cuts the y-axis, will be at the negative place, the negative values of y. I'm going to write that down. Negative values of y. So I'm hoping you guys understand. Had they said C greater than 0, we would be cutting the graph at the positive values of y. I repeat, since C is less than 0, C stands for the y-intercept. What is the y-intercept? It's where the graph cuts the y-axis. Actually, the y-intercept is the y-axis. Okay. Then the question is, where are we cutting the function then? If we are saying C is less than 0, it means we are cutting the y-axis where y is negative. Where is y negative? Y is negative below the x-axis. It's not negative above the x-axis. So what did they say here? They said for each of the following conditions, draw a rough sketched graph on the axes. So let's go. A rough sketch graph, if we were to draw it, guys, would be a graph looking like this. This is rough, guys, very rough. Okay, first and foremost, we can clearly see from the sketch that gradient is what? It's positive. 2, we can clearly see as well that the graph is cutting the y-axis where C marks. Do we get these 2 marks, guys? What do you think? Would we get these 2 marks for our rough sketch? M positive, C negative. Do you think we would deserve our marks there? Do you guys think so? Remember, Nuri said when M is positive, greater than 0, this is the direction of the straight line that we are expecting, not this one, not that one, not this one, but that one. 2, when C is less than 0, we've explained that C stands for the y-intercept. What is the y-intercept? It's where the graph cuts the y-axis. Since C is less than 0, what does that mean? The negative values of y is where we are cutting the y-axis. Where is the negative values of y on our Cartesian plane? The negative values of y are situated below the x-axis. So increasing straight line, M is positive. C less than 0, it's cutting the y-axis at our negative value. Good representation of a rough sketch? I'd say hooray. Okay, let's look at the next one. Draw a rough sketch of f of x is equal to ax squared plus q. Okay, ax squared plus q. Repeat, ax squared plus q, where a is less than 0 and q is greater than 0. So let's look at this, guys. What type of function is this? Straight line, quadratic, or parabola, 3 hyperbola, 4 exponential. Let me go over it again. Straight line or linear? 1. 2. Parabola quadratic. 3. Hyperbola. Or is equal to ax squared plus 2. What type? Okay. I'm hoping there's more people than just Nuri here. Our network is bad, so ooh. Network is taking me for a ride all of a sudden. Yeah, if I could control the network, guys, understand that the network would always be sweet and popping and going well, but it seems like I have no absolute final control over network, unfortunately. My side that the network is good. Okay, that's funny that it's saying that. Yeah, so that means I'm being sabotaged. Grade 10. Okay, guys, please, those who can hopefully hear me then here. F of x is equal to ax squared plus 2, where a is less than 0 and 2 greater than 0. My first question was, what type of function is this? F of x is equal to ax squared plus 2. What type of function is this? Is it quadratic parabola? 2, is it linear or straight line? 3, is it exponential? 4, is it hyperbola? What type of function is this? OGGM. Tomorrow again. Parabola or quadratic? 1. 2. Straight line or linear? 3. Exponential? 4. Hyperbola. And I'm speaking about this function specifically. What type of function is this one? Okay, we've already spoken about that one, but what type of function is this one? F of x is equal to ax squared plus 2. Okay, Nuri is saying parabola. OGGM says straight line. Okay, any other takers on what type of function we have here? OGGM is changing his answer to hyperbola. Okay, hopefully we can all see this function. Okay, all right, let me help resolve. Guys, this is a quadratic function. In other words, it's a parabola. How do we know that? The x variable will indicate it. Okay, the x variable, when it's in the numerator and it's raised to the power 2, that suggests that this is a parabola or quadratic function. Okay, so initially we did this one and we all indicated, or at least Nuri indicated that this is a straight line or linear. This one, guys, is a parabola or quadratic function. F of x is equal to ax squared plus 2 is a parabola or quadratic function. Okay, now let's look at the information we are given. They're saying we must draw a rough sketch of this function where a is less than 0 and q is greater than 0. All right, so let's look at this. A, what does this speak to? A speaks about the what. Before we interpret what it means when it's less than 0, what does this speak to? What is this for a quadratic function? The a, what is this? Okay, what is it, guys? Okay, yes, it is a coefficient, but what does it tell us about the function? Okay, so let me ask that question. What does it tell you about the function itself? The parabola function, the quadratic function. What does it tell you? Okay, it tells us about the shape of the function. Okay, yeah, the shape and the direction of the function. Now, if it's less than 0, what does it mean for the quadratic function? If a is less than 0, okay? So I like what people are saying there. OGGM said it's negative. Yes, a less than 0 means the value of a, the coefficient of x squared, is negative. What does it mean for the shape of the function when a is less than 0? Okay, so hopefully we can learn just from just ordinary stuff that, you know, when you are in a negative mood, it means you are very sad. And when you are sad, you know, you have this kind of face, you know, like this. Yeah, face down. Okay, I like what I like the emoji there, and Nuri has used next to sad. Yes, it's a sad graph. Okay, yes, sad. Okay, they usually say, using other language, they say it's concave down, right? You know a cave, yeah, but it's looking down, so it's concave down. So we usually we call this shape concave down. And yes, sad, sad, because when you are negative, mood wise, you feel sad, right? So that is the shape. So yes, a, guys, the coefficient of x squared for a parabola function gives us the shape of the function depending on whether it's negative, which in this case it's a sad face, it's concave down. But if it was positive, it would be concave up or happy. All right, so it's concave down, sad. Very important, guys. So what are we expecting? We're expecting this shape, the sad face shape, or the concave down shape. Now let's move on. Q. What is this, guys, for your parabola? The Q value tells us what? Let's see in the comment section if people can tell me some stuff that they know about Q for a parabola function. Q tells us, OGGM, definitely the y-intercept. Tell me more, guys. There's more that I'm looking for from you guys. Okay, I love it. Y-intercept. Omolimo, go Omo. Yes, turning point. Okay, two things: y-intercept, turning point. Let's not forget that, grade 10s. Okay, look at this. Look at this. Yes, alien. All right, I like what alien is saying as well. Shifted up or down. Okay, now that's beautiful, guys. I love what you guys are saying as well. All right, so yeah, Q is the y-intercept. All right, Q is also the turning point. So two things for our grade 10s, and that is the fact our quadratic function only has two terms in grade 10. Two terms. This is the first term, this is the second term. It only has two terms. It's only in grade 11 that you get exposed to a quadratic function that has three terms. But in grade 10, guys, it's two terms. Okay, the x squared term and a constant term. That's very important. The Q value is our constant term, and like I said, this Q value represents the y-intercept. It also tells us more about the turning point. Sweet. All right, also let me just say something else. It also tells us about maximum or minimum value, okay, depending on the situation. So sad face, all right, you can imagine y-intercept, we are turning there at the top, so that means maximum value, because at the top, maximum, we are at our maximum, point there. All right, but if it was concave up, happy face, then obviously we'd be talking about a minimum. So that's all important: y-intercept, turning point, maximum or minimum. Now when Q is greater than 0, what does that then tell us? Okay, since we said it's the y-intercept, Nuri is saying he had maximum problems, that's why he's sad. I love that. Okay, beautiful. Thank you for that. That's actually quite smart, quite good. See, you're becoming quite the teacher there, Nuri. Sure, kid is benefiting greatly from that, and I love the ingenuity. That's beautiful. So when q is greater than 0, guys, when q is greater than 0, right, it means that the graph is cutting the y-intercept where exactly? Okay, is it above the x-axis or below the x-axis? Right, where are we expecting to cut? Are we cutting at the above the x-axis, or are we cutting below the x-axis? Are we cutting the graph, the y-axis, where y is positive, or where y is negative, where the y-axis is negative? Okay, so I love it, guys. GM saying above, Ntombentle is saying above, like the beautiful Ntombentle that she is. So that's great, guys. I love this. I love this. So let's just go there and draw our Cartesian plane there. All right, so we know when a is less than 0, because remember, they just asked us to draw a rough sketch. So we have a concave down, that's the first thing. And then secondly, we know that we are cutting the y-axis above the x-axis. So this is a rough sketch, guys. Rough sketch for grade 10. Rough sketch for grade 10. Rough sketch for grade 10. Very rough. Very rough. All right. And remember, we need to make sure that our graph is symmetrical along this line. Because in our grade 10 functions, okay, they are similar x-intercept, just with different signs. You know, if this is -2, that will be +2. If that is -1, that will be +1. If that's -7, that is +7. So it has to be symmetrical. You just need to make sure that that vertical y-axis, you know, on either side we have positive, same values, but positive this side, negative this side. So it's 2, -2, 3, -3, and so it goes. Okay, so guys, I hope we are seeing here how nice it is to sketch functions that are rough just by reading or looking into the parameters. We call these, guys, the a and the q value, we call them the parameters of the function, because these are the things that basically lead to the change, all right, of our function as we observe it with changing values of a and changing values of q. I hope that makes sense. All right, let's look at this one, 4.1.3. This is just helping us to also recap the functions and make sure we understand. What type of function is this, guys? This one specifically. Hyperbola, parabola, exponential, straight line. Yo, look at Ntombentle. Ntombentle was so fast in the typing there in the comment section. It's like Ntombentle was just waiting to pounce onto the answer and give us direction. Yes, Ntombentle. Beautiful, 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 beautiful. Just as the name suggests. There it is. F of x is equal to a over x plus q. Beautiful. All right? Beautiful, beautiful. Okay, so this is a hyperbola function. Now let's go. It says where a is less than 0 and q is greater than 0. Now let's look at this. A. For the hyperbola, what does our a tell us? Hey. Guys, what does the a tell us? If a is less than 0, what is that function? What are we being told about the hyperbola when a is less than 0? Now I need people to really help here now. I need to see who are the faithful listeners, the people that really understand their work for these functions. If a is less than 0 for a hyperbola function, what is that telling us? Okay, Nuri, I see what you're saying there, second and fourth. Always to Mwela, so we are not talking about the same function now. We are talking about the hyperbola. Hyperbola does not have concave down and concave up. Hyperbola has two arms that are represented in different quadrants. So now we need to just check when a is negative, what is our understanding? Okay, so very important. Okay, a first and foremost tells us about the position of our arms on the Cartesian plane. The position of our arms in the Cartesian plane. Okay, a hyperbola has two arms, all right? And rightfully, as Ntombentle and Nuri have said, That means when a is less than 0, when a is negative, it means that our function is found in the second and fourth quadrant. This means even number quadrants. Okay, even number quadrants. Okay, we're expecting to find our function in the even number quadrants, meaning in the second and the fourth quadrant. So beautifully said, guys. Please let's note that when a is less than 0, we expect to find the function in the even number quadrants, meaning the second and the fourth quadrant. Okay, now that's beautiful, and I hope we understand by second and fourth quadrant. Then q greater than 0, what does this mean? What does q speak to? Grade 10. What does q speak to? What does our q speak to? And what do we understand when q is greater than 0? First and foremost, what does the q speak to? Q? No, don't worry, I'll explain just now, OG. The second and the fourth quadrant, I'll explain just now, like when I draw the rough sketch. Okay, q greater than 0, k shift. All right, so remember the q value speaks to the what? The horizontal asymptote. Okay, the horizontal asymptote. It means that horizontal asymptote is not a negative value horizontal asymptote, it is actually a positive value horizontal asymptote. Okay, so it's a positive one, which means the asymptote will be situated above the x-axis. The asymptote will be situated above, because it's greater than 0, above the x-axis. In other words, we'll have a positive horizontal asymptote. Very well said, Bentley, in the comment section. Okay, these are very important. A positive horizontal asymptote, because we are looking at the hyperbola function right now. Okay, so please take note. I want to do this very nicely. In grade 10, we know our vertical asymptote will always be x is equal to 0, no doubt. But if, for instance, I have my x-axis here, remember I said q is greater than 0 for the hyperbola. So for the hyperbola, q is greater than 0. That means my horizontal asymptote is a positive asymptote, like Don Bentley has said. Okay, so that means if this is the x-axis, I'm expecting my asymptote to be right here, because my horizontal asymptote is a positive q value. We together? Hey, I hope we are together here. Now, to OGGM. OGGM was like, I don't understand this thing of quadrants. Guys, please listen very carefully and listen to me very well. Your quadrants are defined by the boundaries of asymptotes. Guys, in and this is horizontal asymptote. It is an equation is equal to horizontal asymptote, and it has a equation. Since q is positive, it means that this horizontal asymptote is situated above the x-axis. So that's why you see it being here for our rough sketch. 2, this y-axis that we have here has the equation x is equal to 0. And in the grade 10 syllabus, because x is in the denominator alone, with no constant term, we know that our vertical asymptote, we know that x cannot be 0, because it would make this undefined. We cannot define the function where x is equal to 0. So we write our vertical asymptote as being x is equal to 0. It is this vertical line. This asymptote, that's horizontal, which is y is equal to q, and this asymptote, which is x is equal to 0, give rise to quadrant. This is our first quadrant. This is our second quadrant. This is our third quadrant. And this is our fourth quadrant. I hope now you are with me. The boundaries make up the quadrants. The horizontal asymptote and the vertical asymptote provide us with the boundaries. So quadrant 1, that's the boundary. Quadrant 2, this is the boundary. Quadrant 3, this is the boundary. And then quadrant 4, within that cage. Okay. Now I'm going to just hang on and hold it right there. I need to check now with my friend who was saying, say, I don't understand this thing that you are talking about. Is there a little bit of light at the end of your personal tunnel there? Okay, I'm going to repeat this again. This is our horizontal asymptote. Y is equal to U. Horizontal asymptote. Then we have our vertical asymptote, which in grade 10 is always the y-axis. X is equal to 0. This vertical asymptote and this horizontal asymptote give rise to the quadrants. Quadrant 1 within the boundaries of the asymptotes. Quadrant 2 within the boundaries of the asymptote. Quadrant 3 within the boundaries of the asymptote. And then lastly, quadrant 4 within the boundaries. So that's what we mean by first, second, third, and fourth quadrant. So if you remember, I asked, if a is less than 0 for this function, what does it mean for this function? And then the answer came that no, this means that a, first and foremost, is negative, which means that the function of the hyperbola is found in the second and the fourth quadrant. You can expect to find the function in the second and the fourth quadrant. What do we see that as practically? It means this, and it means that. This is a rough drawing of a over x plus q, where a is less than 0, that means second and fourth quadrant. And lastly, where q is greater than 0. Where is q greater than 0? It means the horizontal asymptote is positive, so it's situated the asymptote above the x-axis, which should then mean that that is a positive horizontal asymptote. The function is found in the second and the fourth quadrant. Okay. Clear? Comment section, you must let me know there what you think, what's happening there. OGGM, you are the one that basically said this whole quadrant thing is elusive to you, but now you need to let me know if there is a little bit of progress and you can see the light in that deep dark tunnel. In the midst of all the challenges that are happening, can we see the light? Is it clear a little bit? Right, I don't know if the silence means there's a concern or like the network is that bad and we can't hear anything or hear nothing. I hope we can hear something. Then the last question I'm going to do for the night. Okay, I see. Yes, OGGM. I were together. So when A is greater than 0, it would definitely be that it is in the first and the third quadrant. So A greater than 0 means your odd number quadrants. But A less than 0 means your even number quadrants. If you've gotten that down, then we are good. Okay, and the Nuri in the comment section is saying that there's a way that she is able to remember. So maybe if you guys feel like it's not forthcoming, it's easy like that, you utilize those ways of remember. Tom Bentley is already typing like like there's no tomorrow. F of x is equal to a times b to the power x plus q. What type of function is this? Tom Bentley has already enlightened all of us in the comment section and said that is a exponential function. And she couldn't be more right. She couldn't be more right. 100% spot on, Tom Bentley. You beautiful lady. That's true. I agree with you. All right. So there it is. F of x is equal to a times b to the power x plus q. Exponential function. Okay. Exponential function. Now, where a, look at the conditions, where a is greater than 0, b is between 0 and 1. Okay, please understand, this is b greater than 0 but less than 1. In other words, b is between 0 and 1. And q is less than 0. Now let's look at this. A greater than 0. What does this speak to for our exponential function? Okay, so this means something completely different. A greater than 0 means that the function is situated above the asymptote. Okay, anytime that a is greater than 0, okay, a has to do with the position, all right, of the particular exponential function. Okay, so it's either above or below the asymptote. But if a is positive, it means above the asymptote all the time. If a was less than 0, it would mean below the asymptote. Now, this above together with b being between 0 and 1 means that we are above, but we are decreasing. All right. Right. Please understand, this combination is only feasible for when the function is above. But if the function was below the asymptote, it would be below the asymptote but increasing. This is the funny, weird thing about this function. All right. So if it's a is greater than 0 and b is between 0 and 1, then it's above but decreasing. But if a was less than 0 and b was between 0 and 1, it would be below but increasing. So this is the thing about this difference. All right, so I'm looking at this and I'm like thinking, if I see this combination, a greater than 0 and b being between 0 and 1, then it means the function is above the asymptote but it is decreasing. Then lastly, so this here has to do with decreasing or increasing. Then the function, that is it increasing or decreasing? And then q less than 0. That also speaks to where is the function located. All right, the asymptote itself, that's horizontal. Okay, it means that it is, if it's less than 0, it means that the value of the horizontal asymptote is negative. Okay, it's a negative asymptote. Please understand that. Okay, so q has the same meaning for your hyperbola and your exponential function. Okay, because these are the functions that have asymptotes, and your q's both speak to your horizontal asymptote, or in other words, the constant in the function, the constant value in the function speaks to your horizontal asymptote for both functions. Hyperbola is the only one that has vertical asymptote. This one only has horizontal, doesn't have vertical asymptote. So guys, this function, it will be above the asymptote, it will be decreasing, and its horizontal asymptote will be below the x-axis. So this is what I see roughly then. Let's just draw the y-axis, let's draw the x-axis, let's draw in first the asymptote. It's less than 0, so that what we're expecting is it to be here like this. Okay, because q is less than 0, it means the horizontal asymptote is located below the x-axis. Y is equal to q. Our q value is negative, it's less than 0, below that. It's a negative asymptote, makes sense? Then, what did I say? This function will be located above the asymptote. Above the asymptote, but it will be decreasing. So above the asymptote, decreasing. This would be rough. Above the asymptote, say there it is, it's situated above the asymptote, but look at it, it's decreasing the function. Hi, finished guys, finished. I don't know what more you want, guys. That's rough. That's rough. That's a rough sketch. Okay. Okay. Guys, I'm gonna hold it right there for the night. Okay. Yeah, so I'm going to build on this because, yeah, hopefully you guys are seeing that, okay, so once I understand what type of function I'm dealing with and I understand the meaning behind, if it's a straight line, my coefficient of x speaks about the gradient. If it's positive, I look at 4 possible directions of the function. Is it a decreasing function, increasing function? Is it a horizontal line? Is it a vertical line? C, what does it speak about? It's the y-intercept for your straight line function. And if it's less than 0, it means that the function is cutting the y-axis where the values are negative for y. Okay, there's a rough sketch, guys. That was the rough sketch for the first one. Second one, f of x is equal to ax squared plus 2. What is this function? It's a parabola. A less than 0, what does it mean for the parabola? The coefficient of A, if it's less than 0, it means the shape of the function. We are sad. We are sad. You know, we are sad that this guy is finally leaving. Like, we were really enjoying these functions, but he's going. So it's a sad face, you know. It's a sad. A less than 0, it means it's concave down. The shape is sad because when A is less than 0, it means it's negative. When you are negative, you are down, you're feeling sad and all of those things. Make sense? Q greater than 0, remember guys, Q speaks about the what? The y-intercept, the turning point, also the maximum value. All right. Okay, hopefully that makes sense. Okay. Then f of x is equal to a over x plus 2. This is a hyperbola function. So our mindset completely changes when we see this. All right. Okay. So people, please don't confuse these guys, because if you confuse one of these 4 functions and you think it's something that it's not, that's like confusing like your group of friends. Like, imagine if you spend time with a group of friends for the longest time and you knew each one, at least you said you did, and then one amazing day, like, you attach a quality of one of your friends to a friend that you're not supposed to attach that quality. No, I know his favorite color is purple, and you're busy speaking to Cindy and you're like, his favorite color is purple. You even buy Cindy a sweet purple dress with a purple pen and everything like that, but it's Togo who's actually the lover of purple. You've just confused. Imagine how that breaks friendships, just like that. And because it's like you don't care, you're not really bothered. So it's the same thing here. You can't be like, this is a straight line function, a over x plus 2. This is a straight line function. Then you begin to attribute qualities. Say, for instance, a here. You say a, oh, this is concave down. If a is less than 0, it means it's concave down for this function. No, guys, please understand that there's different meaning for each particular function. You can't confuse the characteristics. Okay, please don't confuse the characteristics. I plead. All right. And then we have the exponential, which I just did, and then those were our rough sketches, guys. So guys, I hope that was a meal and a half. So that's just me zooming out a little bit so that you guys can see what it is we were busy with. We're busy with that, drawing rough sketches from the grade 10 functions. And guys, I'll be picking up on this again tomorrow, because I'm just trying to like really go through functions so that the grade 10s can start feeling comfortable and confident with functions, because functions is the new topic for grade 10s, and most of the time, because maybe not enough time is spent during term 2 with functions, a lot of it goes over people's heads, and it becomes a pain not only in grade 10, becomes a pain in grade 11, and it just continues becoming this perpetual pain. We add on new layers next year in grade 11 when we do function. But now the thing is, you need to grasp at least the basics here in grade 10. So we need to make sure they are solid, these concepts. Guys, I'll try and go live at 8:30 tomorrow. It is Wednesday, so I'll try and go live at 8:30, if the latest being 9, and then I'll try and go from 9 until 10:30, and I'm just trying to cover these concepts for functions. And yeah, I hope you guys are really also taking it one step at a time for yourselves, so that you can have greater perception of this topic, and then it can become a walk in the park, a walk in the park. That's what we're aiming for, right? We're aiming for a walk in the park, right? Yeah, right. Okay. Someone asked me for the scope for maths grade 9. Well, it depends which province you're in, but topics covered in term 1, all of them. That's like your real numbers, everything that's there, rational, irrational, your number system, natural numbers, whole numbers. Hopefully you still got a grasp of those definitions for those. Then we have highest common factor, lowest common multiple, how to find those using prime factorization. You can use it as a calculator nowadays and stuff. Then ratio, rate, direct and indirect proportion. Ratio, rate, direct and indirect proportion, together with grade 9. What else is there? Financial mathematics, which means simple interest, compound interest, with a little bit of hire purchase agreement when it comes to simple interest for grade 9. Very important. Then there's like increase of prices, decreasing of prices, selling price, profit, cost, selling price, those things. Increase and decrease of percentages as well. VAT, that's very important. VAT, okay, that's all under financial maths. Percentage increase, percentage decrease, those are very important. And then a little bit of your decimals, right? Just like an understanding, conceptual understanding of that. Then you have exponential, exponents, everything with exponents, simplifying exponents, addition, multiplication, subtraction, the works, man, with exponents. Then obviously equations, simplifying expressions, and then equations, how to solve exponential equations. That's very important, very key. Number patterns must be called to remembrance. Your linear, your geometric figures, geometric diagrams, and the works, just everything that's associated with that. And then series with constant ratio, your sequences with constant ratio, a sequence with constant difference, and then other different types of sequences, with your picture diagrams as well, just the application of your number patterns with that. Then term 2, we come into term 2, algebraic expressions, everything that has to do with algebraic expressions, simplification, that's cubes, roots, cubes and roots and square roots, and just everything that has to do with roots, exponents, cubes, and so forth, squares and everything, squares, square roots, algebraic expressions, monomials, binomials, multiplication of monomial by a monomial, monomial by a binomial, binomial by a binomial, FOIL method. What else do we have in there? Factorization, all types of factorization, simplification, division, multiplication, addition and subtraction, solving for equations, solve for x, solve for unknowns, all different types of solve for x type questions, word problems, then functions and relationships, your flow diagrams, how to find input value, output value, table form of those those functions and relationships. And then I don't know up until where you guys in your syllabus you went up to. I don't know if you guys did linear functions and sketching graphs and finding equations of a straight line, but yeah, that's kind of like roughly up until where you guys should know as far as your term 1 and term 2 work. So depending on the specific province, specific district, I would really encourage you to ask your teacher locally and just ask specifically. Might give you a clear heads up, because different districts around the country may probably be implementing the test and assessment a bit differently, So for instance, where I'm at, learners will be writing an 80-mark June exam on the 13th, all right? And that paper basically will have everything up until, I think, factorization and equations, or if I'm not mistaken. And the whole flow, the whole functions and relationships seems like it won't be featuring in there. Okay, thank you so much. Hope that helps you a little bit. And then, yeah, if you go to my other alternative Maths is a Game page, I've posted some past papers for grade 9 maths, and we'll definitely be posting more as other provinces, right, for your fresh current June exams that have been written in other parts of the country. But thank you so much, guys. I'm going to have to love and leave you. It was really good. I hope you guys had a blast of a time and that it was a fruitful session, this one, for those who are in grade 10. And thank you so much as well, guys, for bearing with me, patiently being there, comment section, listening, the works. I really appreciate your support, and I really appreciate the love, appreciate everything. Thank you, thank you, thank you, thank you, and thank you. Let me love and love you, and thank you again. Maths is a game. Let's play until level 7 becomes the only way, Let's play until level 7 becomes the only way. Oh yeah. Booyah.